How are you? How are you? How are you, my beloved student? How are you, everybody who is watching this fantastic video? I'm very happy to have you today. Welcome into this fantastic moment of learning and enjoying the beauty of science subject, physics and chemistry, and basic mathematics for ordinary secondary education. Whether you're a national or international viewer, I would like to take this opportunity to welcome you into one of our online schools that called TANZANIA Online Ordinary Secondary School in square bracket Olenjolai. Simultaneously, we'll be using multiple platforms, multiple digital platforms to share these contents and to distribute these truths about the beauty of science and mathematics for ordinary secondary education by using different platforms. One of our official platforms is we are going to use we have one of our official YouTube channel that called TANZANIA Online O-Level Secondary School in square bracket Olenjolai. So you know that this is just like a physical school. However, that this is an online school, so we don't have any physical school at this moment. My name is Sir Olenjolai Moko TAYAI Losingo. Those are my phonemes. Sir Olenjolai Moko TAYAI Losingo. My phonemes. I'm a Tanzanian and I'm conducting these programs from Tanzania. This is our national flag. In case you don't know where Tanzania it is in eastern Africa, eastern of the African continent. So we're impacting the world with what that we know and what that we can contribute and with the gift that God has given us. So I'm here to solve your active or your real life problem. I'm here to solve your learning problems of science subjects and mathematics. That's the main purpose of TANZANIA Online Ordinary Secondary School. Solving real life problems, solving problems that are being encountered by the students, solving so many problems that are being encountered by the teachers who are teaching physics, chemistry, and basic mathematics to ordinary secondary students. So that's what. So after I welcome you, then the next question, what are we doing? Yes, what the theme, what the purpose? Why should you be a part of TANZANIA Ordinary Secondary School in square bracket Olenjolai? That's the good questions. So in this online ordinary secondary school, we are really training and teaching some students who will be ready to take advantage of extracting knowledge, understanding, and wisdom from science subjects such as physics and chemistry and basic mathematics, and combine that knowledge with the knowledge, understanding, and wisdom that I will teach them, or we teach them to extract it from the Word of God written in the Holy Bible in order to solve real life problems. Myself, I'm a product of what I'm telling you. I know what I'm telling you. If it's the first time to hear, if it's the first time to practice, if it's the first time maybe to meditate about what I'm telling you about the vision of TANZANIA Online Ordinary Secondary School in square bracket Olenjolai, I agree with you that you say this is completely impossible. How is it possible to combine the knowledge from physics with the knowledge from of the Word of God from the Holy Bible? And then how can you solve real life problems while you didn't specialize? You are studying general physics, you are studying fundamental physics, you are studying fundamental chemistry. Real, even myself, when this phrase came in my mind for my own life, it was actually impossible. But I've been practicing it for more than 7 years right now, and I found that it works and it is possible to combine the knowledge, understanding, and wisdom from science and the mathematics with the knowledge and wisdom, understanding from the Word of God and solve real life problems. Example of the real life problems that Olenjolai solves is the one right now. You are suffering, you fail to learn on your own physics from 1, from 2, from 3, from 4. You fail to learn yourself chemistry from 1, from 2, from 3, from 4 because you don't understand. If you try to learn yourself, or even teachers who are trying to help you, they are really not meeting your demand. So I'm solving your problem. So this is the real life problems. It's not a classroom problems. I've been solving classroom problems when I was in ordinary secondary education. But right now, I thought myself, how can I use the knowledge I gained during my ordinary secondary education to impact the community, impact the present and future generation? So we are training and teaching Form 1 students physics, chemistry, and basic mathematics in 2 languages, in English and Swahili. because the learning language in Tanzania is English. And the learning language in most of the East African countries, for example, Kenya, Uganda, Rwanda, we are using English. So we'll be teaching, we'll be conducting. For the Form 2, Form 3, and Form 4, we are using only English because that's the effective method. We want our students also to learn on how they can learn stuff by using English. So whether you have mastered English or you didn't master, just follow along. You'll understand everything that I'm going to teach you. Again, we are using different teaching methodology and different teaching techniques on breaking down a complex concept that boring and even discourages so many students to quit physics and chemistry and to pursue history, geography, Swahili, English, and other related subjects. That's we call it pure artistic or pure business students, and they quit from the science classes. Really, this the critical problems in Tanzania. So many students, they are quitting physics and chemistry, especially when they get into the Form 3, because they can opt either to be a science students or to be artistic students. I know the many reasons according to my research. They have vision which need the knowledge of physics and chemistry, but unfortunately that they don't have good teachers, and unfortunately that they don't know how to go through physics and chemistry, Form 3, Form 4, and even the entire physics and chemistry. So I'm here to help you, and I'm not here to destroy you. I'm here to help you and to encourage you. You should not give up. If you have opted to be in artistic subject, while you have vision, you hear that from your heart. You want to pursue a particular visions and passions that God has given you a gift, which need the knowledge of physics and chemistry for ordinary secondary educations and for advanced, for undergraduate, or for ordinary diploma. Don't quit. We have so many, we have 4 online schools, and we have also 2 institutions where that we incubate every students, and we can incubate and you can train students almost for 7 to 8 years consecutively. So you have to stay tuned. Again, before we go into today's session, I would like to give you a few instructions on registration to also this the abbreviations of Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So in any physical schools, when you report on the first day, you have to do registration. The good thing that also we don't need students to be registered every term or maybe every year. You just register once. If you register right now when you are in Form 3, then you don't need to register again when you get into Form 4 or when you close the schools or maybe when you are in your vacations. So just register only one. So we say that this is the lifetime registration. All right. The first step, if you don't have an email, open an email, and it can be a Gmail, okay, Gmail account, or it can be Yahoo account, okay. After you have the email, just go to the Google and then ask, how can I open a new email? Then you'll see a new Yahoo email. How can I open a new Gmail? Okay. The second step, we ask you that you have to sign in. You will see a button that you can sign in at the top of your right side. Sign in what? In YouTube. So sign in YouTube by using your email that you have created. So create an email. So open or create an email. So the good way to create an email. Okay. So if you have one, it's enough. You should not create a new email. Just in case you don't have an email, create a new email. If you have it, just sign in by using your username and your password in YouTube by using means that sign in by using your email. So here you will be asked to have a username and password. The third step, when you are in YouTube, we ask you to search Tanzania Online O-Level Seki School in square bracket in Olenjolai. Right? So you have to search this. That's right, Tanzania Online O-Level Seki School in square bracket Olenjolai. If you're an international student, don't be discouraged because of the name of Tanzania. I used to learn different concepts from United States of America that have been taught by different professors in America. I used to learn different concepts from Asian continent. I used to learn different concepts from Australia. So don't worry about the names of Tanzania. That's the name of the schools, because the schools should have a name, right? So don't worry about that one. This physics for the Form 3 is universal. Applications of vector is universal. So every student can cover it and every student can go through it. So whether you're an international student, stay tuned. Don't quit, please, because of the name of Tanzania, right? Then, so send it also. So once you see it, you see the icons or the schools which have round buttons. So you see, and here you have a national flag of Tanzania. So click there and you're already in school. When you're in this school, we have departments just like a physical schools. And those departments, we allocate them in terms of, we call the playlist. Just look the place which has been written playlist. If you go to the playlist, you will see the playlist in a particular schools. So we use to allocate departments, and within these departments, we have subjects that we are teaching them. One of the subjects is physics for the Form 3. There's a special playlist where we collect all the videos of the Form 3 in one playlist. So playlists represent either departments or represent a particular topic or represent a particular subject. So you have to understand that. Again, the first step, we say that after you search this one, then we ask you that you have to click what? The buttons which has been written, subscribe for you to be registered. So there's a buttons which has been written, subscribe. Okay, subscribe. So once you click it, then it's written as subscribe. And then the icons of the bell, will appear. The icon of the bell will appear, and then you see 3 options, and one option is off. Okay. Once you do that, you say that this one, we ask you again to click the icons which has been written share. In order to share the link of this video to all your friends who are in Form 3 in WhatsApp, through Telegram, through Instagram, through Twitter, through Telegram also. Through Telegram, Instagram, Telegram, Twitter, and other, and WhatsApp. Okay, and any other, and so your email also, you can share this link. So share, that's this one. So another thing which you want to tell you right now, so let us go into today. So we have different departments. One of the departments is called physics. We are teaching 4 subjects: physics form 1, physics form 2, physics form 3, physics form 4. And the subject of the day is called physics. And this is this is physics for pre-form 3 or Form 3 students. Then we are in chapter 1 called application of vectors. And this is session 3, adding vectors using graphical methods. Are you ready for the session? Are you ready for session 3? If the answer is yes, then now take your exercise book, take your pen, take your pencil, let us go to the business. So in session 2, basically we've been focusing on, it's been titled as scalar quantity. So first of all, we have defined what the meaning of scalar quantity. What is scalar quantity? So we define, okay? Hence, we've given you some examples of what? Of scalar quantity. Examples of scalar quantity. Okay, quantity. So we mentioned examples of scalar quantity. Example, say distance, it's a scalar quantity. We have temperature, it's a scalar quantity. We have mass, it's a scalar quantity, etc., etc. So scalar quantity is any quantity which have only magnitude, does not have any direction. Again, in this session, we presented to you about, we say that it has only magnitude, so magnitude. So presented in terms of diagrams, so that for example, that we want a distance is a distance from A to B, we don't have directions, whether from A to B or B to A. Okay, why we have 2 options. Again, we defined, or we taught you, definition of what? Of vector quantity. Of vector quantity. What do you mean of vector quantity? We say vector quantity is any physical quantity which have both magnitude and direction. So here we say that for this one we have only magnitude, or we call it size. While for this one we have both. We say that magnitude, we have to check the magnitude of the vector, and what? And direction. And direction. Okay, and direction. So then that is the second definition. So we have examples. Examples of what? Examples of vector quantity. Vector quantity. Okay? Examples of vector quantities. So examples of vector quantities, I mentioned we have velocity, we have displacement. So these are the common one. We have pressure. We learn pressure during our form one. We have force. We have torque. We learn in equilibrium torque. We have also acceleration, etc., etc. So in case you want to access the contents of session 2, just sign in, just create an email, then send in YouTube by using your email, and search Tanzania Online O-Level Circuit School, the square bracket Olenjolai, and then click the button subscribe, and then click share. I didn't tell you why should you subscribe. We have a vision. Right now we have more than 80 videos in our Tanzania Online O-Level Circuit School in square bracket Olenjolai. But we expect you to record more than 400 videos. So, and every day we'll be adding at least a single video. So we want you to be the first one to be notified when we add a new video, because we know that we are serious students. Because in this channel, in our YouTube channels, in these programs, we are going to teach you all the topics of the Physics Form 3. Wonderful. All the topics of Physics Form 1, all the topics of Physics Form 2, all the topics of Physics Form 4. Wonderful. That's good news. So whenever we add any new video from today that you are watching, if you're new with you, if you've subscribed, that is fine. Keep on enjoying the beauty of physics, chemistry, and mathematics for ordinary secondary education. But if you haven't subscribed, subscribe now before you forget, in order for you to get notification. Whenever we add a new video, you'll get notification that there's a new video has been added into also. So you can go through it at, within the specified times or within the targeted time. Okay? So today we are going to deal with adding vectors using graphical methods. Okay? So we say we have two physical quantities, right? So we say that let us start with basic operations. Before we deal with adding vectors, let us aim is basic operations of what? Basic operations. Say with me, basic operations of what? Of scalar quantity. So before we deal with vector quantities, let us deal with scalar quantities. Scalar quantities. Okay? So we say that we have a very interesting sentence. Since we told you scalar quantity scalar quantities have only magnitude, scalar quantities have only magnitude. So we can add them normally. So they can be added. That's the meanings of basic operations. Basic operations means plus, minus, multiplication, and division. So they can be added or subtracted or multiplied or divided from each other, usual, okay? Multiplied just as usual numbers. Usual numbers in physics or in mathematics. In physics. So that's the first sentence. Since scalar quantities have only magnitude, so we can add them, or subtract them, or multiply them, or divide them, just as usual numbers in physics. What does it mean? Let me give you a simple example to illustrate that sentence. Example, add 30 volume is a scalar quantity. 30 centimeter cube of water into a beaker that contain 20 centimeter cubic of concentrated hydrochloric acid. This is the abbreviation concentrated hydrochloric acid. So we say for this case, we say that the total volume of hydrochloric acid now is no longer concentrated, will be 30 centimeter cube plus 20 centimeter cube, because this is scalar quantity. So 30 plus 20, this will make the total volume of the gas of the hydrochloric acid. So total volume of hydrochloric acid is 50 centimeter cube. 50 centimeter cube for this case. 50 centimeter cube for this case. So simply say that addition for the basic operation, so the basic operation of scalar quantity or scalar quantities does not need the use of the graph. That's the case. So please copy the steps or procedures that you have to follow for you to register yourself permanently into also to enjoy the beauty of 12 subjects for the ordinary secondary education. So pause the video and copy the steps. I think that you're done, right? So let me clean this blackboard. So it means that if you want to add any scalar quantity, we don't need a graph, right? So for instance, that maybe you want to find maybe resultant or maybe total distance traveled. So total distance traveled, okay? So maybe total distance traveled. Maybe you have somebody has traveled from point A to point B, and then he traveled point B to point C. So the distance from here to here, let's say it is 2 meters, and the distance from B to C, this is what? This is 3, let's say it is 3 meters. Okay? So it means that now to find distance from what? From A to C, not displacement, to C. This will be equal to 2 meters plus 3 meters. So the response is equal to what? The response is equal to 5 meters. So no need for the direction. So it means if you've been told that Olenjolai traveled from point A to point B, and the distance between A and B is 2 meters, and I again travel from point B, and then travel between the 2 points B and C, which are separated by 3 meters, hence in words, just we can do that problem. We don't need the graph. We don't need the graph to add. That's why, because it's possible for me to travel from A to B and B to C, or C to B and B to A. That's why we call this the scalar quantity. I believe that you have the overview of adding scalar quantity. So when you will be given to add or subtract or multiply or divide scalar quantity, you should not bother yourself whether to use a graph. We use a graph for the vector quantities. Okay? The vector quantities. So you say that unlike addition of scalar quantities. Unlike addition of scalar quantities, like additions of scalar quantities, the vector quantities okay, the vector quantities can be added conveniently with help of vector diagrams. So unlike addition of scalar quantities, the vector quantities can be added conveniently with help of vector diagrams. So whenever we want to add two vector quantities. For example, we want to add maybe one force with another force, because force is a vector quantity. Then we cannot do it easily like how we have been done it when we've been adding the two scalar quantities, maybe volume of water and the volume of water, instead of centimeters of water with 20 centimeter cubic or 40 of concentrated hydrochloric acid. So for this case, we need the help of 40 of a graph. And this graph, it's a just representations of 40 vector diagrams. So that's why that we say that we need the help of 40 of vector diagrams. So now, what is vector diagram? Let me teach you first about vector diagram. Remember that we are focusing on what? Adding vectors using graphical method. Vector diagram. Vector diagrams. Okay? A vector quantity can be represented vector quantity can be represented on paper by using a directed line segment. So directed line segment. Say directed line segment. Say again, directed line segment. Directed line segment. For the scalar quantity, here we use the line segment. It's the line segment from A to B. But for the vector, we have to use directed line segment. What the means of directed? Directed represents direction. So directional line segment. This is non-directional line segment from A to B, from B to C. Non-directional line segment. Okay? So the line segment is just like this. This is the line segment. Line segment. So this is figure 3.1. That this line segment has the beginning, has its end. So that line segment. Okay? So again, want to focus on what? A directed line segment. What it means of directed line segment. Because the graph which you are going to discuss, we are going to learn in session 3, in session 4, in session 5, possibly even in session 6, will be representing what in line segment. Directed will be representing directed line segment. So the directed line segment is this. It can be like this one. This we say that this is figure 3.2. So we call it directed line segment. Directed line segment. So it's directed line segment. Directed line segment. So directed line segment. So now we say that we can present a vector with this directed line segment. So we can present a vector as line segment, and this line segment has mainly two parts. This we call it tail or vector, and then this one we call it head, and this we call it an arrow, usual, okay? And then so head, and then this is tail of a vector. So tail of a vector, and this is head of a vector. Okay? And then we say that the length of the vector from here to, let's say from here to possibly to this point, because this is still continuous. So this representing what? Length. So to avoid confusion, so the length, this one representing what? So this representing what? Length of or magnitude. Length of a vector or magnitude of the vector. Okay? So length of the vector or magnitude. So this is figure 3.3. So it's a representation of a vector. Representation of a vector. Representation of a vector. We have different ways of representing a vector. You can have also line segment like this. And then the arrow is not at the end. Okay? So, for example, you can have maybe 3 Newton. So force is equal to 3 Newton. So this is initial point, let's say from point A to point B. So that's the vector also. It's a representation of a vector. Okay? We have arrow, and also so this arrow representing one direction, while we have tail. Okay? So you have again another vector line for another vector like this, that may be from point O to point P, and then the vector or the arrow is like this. This is the vector. Right? So you can have a different style. You can have horizontal vector. This is OQ. So OQ, and then the arrow like this. So this is figure 3.4. So we have different vector diagrams, or vector diagrams, different style of drawing vector diagrams, depends on the direction. Again, in case you feel from your heart, we are delivering this content free of charge right now for this time, for this year. But in case you feel from your heart you want to offer our God your free willing thanksgiving for what He has given to you, because the sponsor of this, of Tanzania Online Ordinary Secondary School in square bracket Olenjolai, is God Himself, right? So you can offer your free willing thanksgiving to Him through this program, and you may send your free willing thanksgiving right now before you forget through 0759745331. And your free willing thanksgiving will be used to pay the running cost for more than 500 videos of ordinary secondary education in physics, chemistry, and mathematics being recorded and being uploaded and published publicly to help present and future generations, including even my children's. Okay. So these are the different, okay? So then we have to deal with some phenomena. And this is the magnitude, and also we have direction, okay? So we have something we call it magnitude. Magnitude. Say with me the magnitude of a vector. Magnitude of a vector. Magnitude of a vector, okay? So we say that in the vector diagram, the magnitude of the vector, the magnitude of the vector is represented by the length of a line segment, of the line segment, of the line segment, the length of the line segment. So in vector diagram, the magnitude of the vector is presented by the length of the line segment. So this one. So from here to here, this is magnitude. From here to here, this is magnitude. From here to here, this is representing magnitude. So that's what we call length or magnitude of the vector. Okay? So very important, because we say the vector has both magnitude and direction. So we will focus on magnitude. So magnitude is a length. So for example, that if you have a vector from A to B, and its direction is from, if you have a vector from B to A, okay? So it means that the distance from here to here, this one, this is what we call the magnitude, the length. This is magnitude of vectority BA. So this is called the vector BA. These are indicating that B is the tail, while 8 is what? 8 is a head of the vector. Then we need what? So B, we have direction of a vector. How do we represent direction of the vector? Direction of a vector. Direction of a vector. So in vector diagram, in vector diagram, the direction of a vector is shown by what? By arrowhead. Arrowhead at the end, along or at the end of what? Of line segment. Of line segment. So in vector diagram, the directions of a vector is shown by arrowhead along or at the end of the line segment, or at the end of line or line segment. In vector diagram, the directions of the vector is shown by arrowhead along or at the end of the line segment. So what does it mean? For example, if you consider, so this is figure 3.4 and 5. So in figure 3.5, we have A to B. So this one representing what? This is representing direction of vector BA. Direction of vector BA. Okay? Direction of vector BA. So here also you can have magnitude that, let's say we have velocity is equal to 3 meters per second. Here we have also another torque. Torque is equal to 3 or 30 Newton power. Newton meter of the torque. Okay? So the directions of that one. So it means that now this is the vector point. So head representing what? An arrow. Or even at this point, this one representing direction. Okay? And then we have two phenomena which are very important for the next concepts. Okay? So this presenting directions of what vector B. Then we say that I will have B again, another 2, this is C. Okay. Tail of a vector. So we say a tail of a vector is the beginning of any vector. So a tail of a vector is the beginning of any vector. Okay? Then we have again another phenomenon called the head of a vector. Every vector should have a tail, and every vector should have what? Should have a head. Just like myself. For me, I don't have a tail. Just like a goat. A goat has a head and also a tail. Just like a cow. It has what? A head and a tail. You don't have a tail, but you have a head. Okay? It doesn't mean that you're not a vector, no. These are the physical quantities. Head of what is of a vector. So we say that a head of a vector is in the end of what? Is the end of any vector. The end of any vector. So for instance, you can have a vector like this. So this is point A. So point A, that's why we wrote this is tail and this is head. Tail of a vector and this is head of a vector. Maybe that can have that this is 3 newtons. So force is equal to 3 newtons. So this is magnitude. So you can just write 3. So magnitude 3 newton, but from point A to point B. So this is the tail of vector, this is the head of vector. Tail of what? Of vector, beginning of a vector, and this is head of what? Of a vector. These terminologies are very important. This is just still figure 3.5. So this is figure 3.6. So tail of vector, head of vector. Okay? So this is tail of vector and that is head of vector. All right. Okay, so that is about it here. So I believe that at this moment, you know the meaning of tail of a vector. So you know about vector diagram. You know the tail of a vector, you know the head of vector, you know the magnitude of vector, you know the directions, and you know how to show them in the vector diagrams. It's very important. In case you didn't catch up at any point, please review or watch these videos twice, 3 times, 4 times, 5 times until this concept has been built in your mind, because that's why we begin with applications of vectors. Later on, we are going to deal with different physical quantities, which are vector quantities. So we'll be using the vector diagrams. And this concept, you have to keep it, because I want to tell you, in many topics of advanced physics, for example, in mechanics, in electric, it means that in magnetism, also many topics of what in vibrations, it's a little bit for vibration, but in electrostatics, right? We'll be using these concepts of applications of vector or vector diagrams, because we'll be representing forces in vector diagrams, electric fields in vector diagrams, magnetic field intensity. Electric inversions is Newton's law. So we'll be resolving forces, something we call resolving, which is the last subtopic of this topic. So you have to understand and keep this concept for the rest of your life, even if you'll be studying undergraduate concepts or you'll be undergraduate in engineering or science. You are going to use the concepts of vector diagrams. So it's very important concept in all aspects of mathematics and in all aspects of science and in all aspects of engineering, in all aspects of applied physics, right? So keep it in your mind. Again, we say that we have, or we like just to deal with what? So, okay, so now we have an idea of vector diagram, right? So then we say that vector addition. So let us focus on vector addition, okay? Vector addition, have a certain vector. Okay, so vector addition. So we are adding vectors using graphs. So we want to see the condition before we go there. Vector addition. Vector addition. Vector addition. Say with me. Vector addition. Vector addition. So in physics, when 2 or more vectors, act on a body. Okay, when 2 or more vectors act on a body, when 2 or more vectors acting on a body are added together. So we say then the Year summation the year summation is called what? Resultant vector. It's called resultant vector. Resultant vector. So in physics, when two or more vectors acting on a body are added together, then the year summation is called the resultant vector. When two or more vectors acting on a body are added together, then the year summation is called the resultant vector. The year summation is called the resultant vector. So, we are going to deal with resultant vector when we add in two vectors by using the graphical method. So, the question now, what is resultant vector? Yeah, what is the resultant vector? You have to understand. Question, what is, pause the video and ask yourself, what is resultant vector? What is resultant vector? What is resultant vector? Okay? What is resultant vector? That's the question. What is resultant vector? Okay? So it's a resultant vector. Resultant vector is a net effect or summation of two or more vectors acting on the same body. That's the meaning of resultant vector. Resultant vector is a net effect or is a net vector. So it's a net vector or is a summation of two or more vectors acting on the same body. We cannot find the resultant vector of the two vectors which acting on the two different bodies. That's why we are limiting. So we'll be dealing with vector diagrams, we'll be dealing with resultant vector. So for us to mean that in order to understand the additions of vectors using graphical methods, then we really encourage you that you have to make sure that you understand the vector diagrams and you understand the resultant vector. That's all. Because I'm going to teach you three graphical methods of adding vectors. Very simple, three methods, and you have to remember them. When you'll be learning additions of vectors in mathematics, or we'll be learning graphical representations of two-dimensional or three-dimensional vectors in mathematics, which I know that you'll encounter it in advanced mathematics or in ordinary educations, ordinary diploma educations for the basic technicians, you will encounter it in the topic of vector in mathematics, and even in physics, in applied physics, you'll encounter it. So this is what you have to we have to take consideration, that resultant vector is a net effect or summations of two or more vectors acting on the same pattern. All right. Okay. So if that the case now, if that the case is the net effect, okay, if that the case, wonderful. You say that, okay, so you're looking for resultant vector, ladies and gentlemen. Ladies and gentlemen, resultant vector. So we say that, not. You have to not before. Not, number one. Only like vectors, when you say like vectors, it means vectors of the same physical quantities. Like only like vectors, it means same physical quantity. Okay, make what? Make the resultant vector. Make resultant vector. Only like vectors. Only like vectors. Or vectors of the same physical quantity. Make what? The resultant vector. The resultant vector. Only that. What does it mean? Example. You have a resultant. You can have resultant displacement acting on the same board or on the same boards on the same jam. So you have to take displacement to 1. Displacement to 1 plus displacement 2. If there are 2 components, if 3, you just take displacement 3, displacement 4, etc. etc. Okay? We can have resultant force. Resultant force. So resultant force, it can be force 1 acting on the board plus force 2 acting on another board, can be plus F3 acting on the same board. So we are just illustrating the fact that we only add like vectors to make resultant vectors. Resultant vector is single vector, but component vector are more than 2 vectors. Okay? Also, you can have a resultant what? You can have resultant velocity, okay, of a body. So it can be V1 plus velocity 2 plus maybe velocity 3, it depends, plus velocity 4. Maybe you have 4 components, but we didn't choose 2, the maximum is 3, 4. So it means that the resultant displacement, resultant force, and resultant vector velocity will be possible because remember that here F stands for force, while here is where here V stands for velocity. Okay. So that's the first note. Second note. It means that so it's not possible to make resultant vector of what? Of unlike vectors. Unlike vectors or vectors of what? Different physical quantities. Different physical quantities. So this is not possible to add them different physical quantities, plural. It's not possible. It's not possible to add them. It's not possible also to add them, and it's not possible to subtract them or to do anything else. So it's not possible to make resultant vector of unlike vectors or different physical quantities. What does this mean? Examples. It's not possible to have maybe resultant vector of what? Certain vector of velocity plus what? So this is not possible. That's the meaning of an equal. Velocity plus what? Plus force. Why? Because these are the two different physical quantities. You cannot add velocity and force. That's the meaning. Again, we cannot form resultant velocity or resultant vector of this. So it's not possible. Take a vector quantity, which is pressure, maybe plus torque. This is not possible. Plus torque. Also, it's not possible to make a resultant vector by using these two physical quantities. By using acceleration plus what? Displacement. Plus what? Displacement. Acceleration plus displacement. So it's not possible. This is not possible. So those are cases. So because the session is called adding vectors using graphical methods, we need all of these concepts, and I've been building the concept, the foundation. So right now, ladies and gentlemen, let me mention methods of adding vectors using graphs. I'm about to end this session. Methods of what? Methods of adding vectors. Methods of adding vectors. Method of adding vectors by using graphs. So methods of adding vectors by using graphs. So he said that in physics, there are three basic methods of adding two or more vectors by using graphs. So in physics, there are three basic methods of adding two or more vectors by using graphs. Don't want to confuse you, just want to encourage. So these methods are, the first one is called what? It's called the head to tail method. Head to tail method. The second one is called the triangle method, where we are going to teach you about triangle law, which has been seen in different past papers to state the triangle law or triangle rule. And the last one is called the parallelogram. Parallelogram method. Method where we are going to state parallelogram watching law. Okay? So, in order to save your energy and to save your capacity of accumulating some other contents. This is the end of session 3. I would like to say this is the end of session 3. So right now, let me leave for you homework 3. Homework 3, which you have to submit in the comment sections or in my email that I will give you later. So the question is, explain briefly. Explain briefly. Explain briefly triangular. Triangular. Okay, but I think that the best way explain, explain briefly triangle. Triangle method. So, triangle method with 8 or 40 of examples. That's the question. So this is example 3. This is example 3. So homework 3 and example 3. So explain briefly the meaning of triangle method and how we add 2 or 3 vectors. There we add only 2 vectors, right? How we add the 2 vectors by using triangle method. Just simply try your level best. You can discuss with your colleague, you can discuss with your classmate, and then everybody has to write his own work and you have to understand what you've been discussing. So you can try. So in the next session, which will be session 4, I'm going to teach you about head to tail method and triangle law, and I'm going to state one law. Then in session 5, I'm going to teach you about parallelogram method. Parallelogram method, which is very useful methods, and then we'll go into the concepts of relative velocity, and later we'll go to teach about resolving of the forces and other subtopics. So this is the end of session 3. I love you so much, and God love you so much. And I'm very happy, and I thank God. I would like to thank God who have been with me in just developing this idea from analog or physical teaching into digital or wireless teaching. The entire nation of Tanzania, the entire African continent, and the entire world for ordinary secondary students right now, I can manage to do it. Why? Historically, I was just teaching a small group of students that I found physically in the class. So may God bless you. I thank God who have given you opportunity to join me. I would like to invite you in the next session. Join me in session 4, where I'll be teaching about triangle method, and I'll do the corrections of the homework 3. So you should not miss. Remember to register yourself by subscribing into our YouTube channel. Remember to go through session 00, general introductions of physics form 3. Remember to go through session 1 and session 2 of scalar, of applications and vectors, or we call it scalar and vector quantities. And also invite your friends, share this link of this video, ask you questions in the comment section, answer questions in the comment section, establish the group discussions by the comment sections, discuss with other students across the country of Tanzania, and have to share these contents because they can access them in any zone of Tanzania. You can access these contents in Lindi, in Mtwara, you can access these contents in Mara, in Musoma, even in Shinyanga, in Bariadi, in Simiyu, and even in Kagera, in Gate, you can access these contents, even Dodoma. So any students can access, even those students who are studying in Wadi School. This is the light right now coming in your mind in order to make sure that you achieve your goals in science and basic mathematics. May God bless you and keep you. This is Sir Olenjolai from Tanzania. I love you so much. And hence, let us meet together in the next session. May God keep you until we meet.